For a long time, I thought I was a guy experiencing the universe until I realized I was the universe experiencing a guy.
Is it just me, or is that the sound of a physicist who just jumped out the window?
There is a universe where the internet only contains quality videos of strange metaphysical entities filming themselves unboxing universes. And another universe where you wrote this video and I'm the one watching it, but in this one, that's not the case. Anyway, in the previous episodes, we explored the extraordinary hypothesis of the multiverse until we gave ourselves nosebleeds. But without actually explaining why, this hypothesis that the universe we live in is not the only one, but one among thousands, millions, billions, and infinity of others, isn't so crazy after all. In fact, as strange as it may seem, this hypothesis is actually extremely reasonable. Quite simply because in this universe you can listen to me, because I'm able to speak, because there are dogs, cats, flies, amoebas. And the existence of all these living things supports the validation of the multiverse hypothesis. Okay, it might sound silly, but stay with me for a moment. We're going to unfold the reasoning. I'm willing to bet my own life that you're going to agree with me. If I tell you that there is life in our universe, okay, so far, so good. And so we can say, without hesitation, that the universe allows life to appear. Captain Obvious, thank you. As a result, there is an infinity of universes. Now, that's not working at all. Don't leave. We're going to reframe the reasoning and ask the question differently. How is it that there is life in our universe, given that there seems to be an infinity of possibilities for it to have been otherwise? Let me explain. When we study the fundamental laws that govern the behavior of matter in the universe, there's always, invariably, something very strange that jumps out at you right away. In fact, if the value of the fundamental constants of nature were even slightly different, just a tiny bit off, let's say by a millionth of their value, by a millimetric fly's fart, then the entire universe would be radically different. Life as we know it couldn't have emerged, and we wouldn't be here. To understand why, let's take a moment to look at these constants. The functioning of our universe is governed by natural laws that tell matter how to behave, light how to travel, time how to flow. And at the heart of each of these laws are fundamental constants, such as the maximum allowed speed, the value of the elementary particle masses, or the range of forces in space. And, in a sense, these values control how long stars can shine, the types of atoms they can create, the way molecules bond, and how light interacts with matter. In short, what is possible and not possible in our universe. And where it gets interesting is that, obviously, we are alive, but it could have been, maybe it should have been different. In fact, everything suggests that these 20 or so fixed quantities, these constants, seem to have exactly the right values. Like the dials of a gear wheel finely tuned to the exact notch to allow the emergence of life. And if you change even slightly the value of one of these constants on paper, you fundamentally alter the laws of nature, and you end up with a universe incapable of producing galaxies, stars, planets, or life. To realize just how extraordinarily fine-tuned our universe seems, put that in quotes, let's take a few examples among many others. In nature, each element either has the ability or not to bond and interact with other elements, governed by the shape of the complex structure of electron shells that surround their atomic nucleus. And it's the sum of these interactions that makes existence possible, or not. Of all the molecules we know, molecule, able to arrange themselves to form structures of crazy complexity and rather pleasant to live in, like you or me. But if you move the slider on paper, the values, the constants, found at the heart of electromagnetism or the strong nuclear force, then the stability of atoms is profoundly disrupted. And these can just as easily collapse or explode. Increase it on paper by even 0.5%, upwards the range of the strong nuclear force. And by doing so, you disrupt the entire chain of synthesis that, at the heart of stars, drives the transformation of elements into others. And you would end up with a messed up universe, a universe almost completely devoid of carbon, the basic atomic element used by life. On the other hand, if this so-called strong nuclear force were a bit weaker, then you would make elements that are usually unstable perfectly stable. And this small change would have major consequences, because we would end up with stars burning through a kind of superfuel extremely quickly, to the point of leaving our universe without light as a result. In the same way, if the value of the electromagnetic force had been just 4% lower than what we know, there would be no hydrogen in the universe, the element that is, in our universe, the most abundant. And we could multiply the examples by thousands, because many other tiny variations in the mass of electrons or quarks also, once again, lead to a cosmos without chemistry and therefore without life. One last example before we go. If you slightly altered the strength of the vacuum energy, you would change the rate of expansion of space. This would result in a universe where matter could never have clumped together, and therefore where no structure would ever have formed. In short, even with slightly altered values, you could end up with a universe that is extremely different. Filled with a fog of subatomic particles, formless stars unable to ignite, or, on the other extreme, burning too quickly. It was that close, but just a little bit off, and the world as we know it wouldn't exist. And where it gets really strange is that, as far as we know, there's no apparent reason or logic for why these constants have the values we know instead of others. So, we have every right to wonder, why is the mass of the electron exactly what it is? And everywhere, all the time in the universe, it's always invariably this damn value? Why is a neutron precisely heavier than a proton by that amount, and not a little more or a little less? Why is the force of gravity 10 to the 36 times weaker than electromagnetism? Why such a difference? Why isn't this value that one or any other? Why? Well, we absolutely don't know, and we will most likely never know for sure where the seemingly subtle tuning of these parameters comes from. Why are they like this and not otherwise? But we can nevertheless identify three possible types of answers to the monumental question of where this strange balancing act comes from. The first possibility is to consider that there is one and only one universe, ours, and the values taken by the fundamental forces of nature are purely arbitrary. In that case, the appearance of life is the result of an extremely lucky chance, a chance that physicist Lee Smolin had fun calculating. He comes to the estimate that just to allow stars to appear in our universe, by initially assigning completely arbitrary values to the fundamental constants of nature, there was a 1 in 10 to the power of 229 chance. At that point, it's no longer luck, it's insolence. Second possibility, our universe is still unique, baby, except that there's no such thing as chance. And the values of the forces of nature were finely tuned from the start to allow life to appear. In other words, we just happened to land on the right settings to allow us to exist. Because ultimately, behind all of this, at some point or another, there's a god or baby deities hiding. Or even extremely advanced forms of life. And in that case, it's Bibi who tinkered with the buttons and cooked up a splendid simulation for us. Or we can consider that it's absolutely not necessary to go through the apparent little miracle of the fine-tuning of the constants of our universe. As long as we consider the existence of other universes besides our own, that there are others out there, thousands, millions, an infinity of other different universes raised within a multiverse. And that's the third possibility, the one at the very top of the podium. According to this one, we are neither lucky nor desired. There is no chance, no divinity, or necessity. Only the number of attempts matters. There are so many different universes that some, like ours, have the right settings to accommodate us. And since we are alive, well, it has to be in one of them, in a universe capable of producing observers, that we find ourselves. In other words, an infinite number of other universes would exist with different values for the constants of nature that we know. And among these infinite possible alternate universes, an immeasurable number of them are like bad, tuned, unsuitable for the emergence of life, while in others like ours they frolic on hospitable lands. So from the perspective of life, it seems we have won because billions of other universes have failed. Missed again. Yes, it works. In fact, if the laws of nature seem miraculously favorable to the emergence of complexity, it's simply that elsewhere in other universes where different conditions prevail, they are not at all. In the same way that our planet is a little paradise hosting life, which is not representative of the thousands of worlds we've discovered and which are, most likely, much closer to hell. So, the answer to the question, why do we live in a universe where at least the surface of one planet is teeming with life becomes because there are an infinite number of other different universes which are empty and desperately sterile, and in which no one has ever appeared. To realize that no arrangement of complex matter is wasted there. And, in a sense, The multiverse hypothesis is a logical deduction, because with this view, there's no need to tear your hair out trying to understand the apparent fine-tuning of the initial conditions of the cosmos that allowed life to appear, given that there necessarily exist, among all the possibilities contained in the multiverse, universes that have the properties of another. Thus, the question of why nature obeys certain laws rather than others completely loses its meaning and relevance. If the universe seems to us to be tuned with the precision of a watchmaker, it's because nature only shows us one of the mechanisms at work. While there are billions of others elsewhere, poorly arranged, rusted, I can see some of you bleeding gray matter of all colors from your noses. But keep in mind that the hypothesis of the existence of a multiverse didn't just magically pop out of a rabbit's hat on acid, but it slowly grew inside the minds of theoretical physicists before becoming established. Because the multiverse hypothesis follows from logical theoretical consequences of our current understanding of the laws of physics, in other words, we started to consider the existence of these other universes as plausible. By studying ours, take an infinite universe as ours might be, and by studying it, you inevitably end up with the concept of the multiverse lurking somewhere in a corner. Take an inflating multiverse like ours, sprinkle it all with a dash of quantum physics, and you might end up somewhere on paper with some big clear traces of the multiverse. Try to unify general relativity and quantum physics, and you might once again naturally see the idea of other possible universes emerge. In fact, as unsettling as the hypothesis of the existence of multiverses may be, we know of half a dozen serious scientific arguments that lead to this possibility. Do some theoretical physics on paper, look away, and millions of other worlds have insidiously settled on your couch as so many logical consequences, which by no means implies that their existence is confirmed. But everything suggests that this hypothesis has a lot to tell us. And yeah, I'm giving intention to a universe. In short, to sum up, when we look into the multiverse hypothesis, it's better to keep an open mind while also guarding its access strictly. Because this hypothesis isn't really a scientific theory in the sense that for now it's impossible to prove but also impossible to refute. And in doing so, it's less of a theory than a concept that confronts us with two huge problems. On one hand, the multiverse hypothesis allows for so many other realities that could explain practically anything and everything that it makes all observations necessarily compatible with one of its interpretations. On the other hand, if these other universes exist, by definition they are in other universes and therefore do not interact or interact extremely little with ours, which should make them as easy to detect as a fart from a hypothetical ghost at the other end of our universe. That's why, for now, we have no evidence for the existence of the multiverse, other than what comes from a kind of thought experiment deduction. Well, actually, to be completely fair, we do have a few leads to test the existence of a very small number of introns. For example, there could be something in the cosmic microwave background, that tired light coming to us from the Big Bang. Patterns of hypothetical remnants of alternate universes that may have interacted with ours in the past, or from which we might have originated. And the funniest thing about all this is that even if we could prove the existence of one of the multiverses, yes, there could be quite a few different types. Do you have an episode that talks about that over there? Well, that would only push the fundamental questions we can ask about the nature of the universe even further. Questions that, in the end, would still keep coming up. But this time about something bigger, the multiverse. Chance, destiny, necessity. You may well have an opinion on that, but it will almost certainly and forever be impossible to decide. In any case, I hope that in this universe at least I was able to make you feel a bit of that vertigo one can experience when faced with the idea of the possible existence of the multiverse. So clearly this video has only scratched the surface of the subject, but we can be reassured. There might be a universe where I was much more precise, and here you are, God. An ordinary planet sailing in an ordinary solar system, drifting within some random galaxy in a universe that is also ordinary on a cosmic scale, among an infinity of other different universes, and unanswered questions like this one. And why are you still here, asking these questions with me?
Follow me on Insta. I sometimes share some of my other wanderings there.
To learn more about the types of multiverses, go this way, and for something much lighter, go here. And subscribe and share all of this for me. In this universe,